In these two examples, we are going to keep on practicing working on substitution in order to do our integration. It's called U substitution. Types of things that we're looking for is if we were to have done a derivative, would we have a chain rule kind of feel going on with this? Something like this, where you have something on the inside raised to a power, where we do have something inside raised to a power. We have a fractional exponent. We have a chain rule that would have happened, so we have to use a U substitution to undo this chain rule. The other big thing that I'm looking for is that if I were to take the derivative of an x cubed, I get an x squared. I'm not totally worried about the coefficients matching up as long as the powers match up. So if I do the derivative of this, I'm going to get this. So let me start with that, and that tells me that that is my u. So it's a 1 minus 4x cubed. And if I do the derivative of that, I get a negative 12x squared dx. So see that x squared dx? Let me rewrite this a little bit to kind of help our cause. So first thing is I'm going to take that 2 and pull it in front. And then I'm going to make this a 1 over the square root, 1 minus 4x cubed. And then that x squared, I'm going to pull off of the fraction and put it next to the dx. So there's our x squared dx, so I can sub out with a du. However, I don't have a negative 12 in here. So then let me divide that over. So it's a negative 1/12 du equals x squared dx. And there's our perfect x squared dx. And we can replace it with negative 1/12 du. So that negative 1/12 is another constant. So I'm going to pull that with 2. So I'm going to have a negative 1/12 in here. The integral of 1 over this x squared dx. Now it's just going to be replaced with the du, the negative 1/12 I already have on the outside. And then at the same time, this piece, I'm going to go ahead and sub it out with u. So I'm going to make it the square root of u. So that's really what I'm going to do the antiderivative of. So let's get it ready to do the antiderivative. So this is going to simplify out to a negative 1/6. I'm going to pull this up and turn it into a fractional exponent. So it'd be a negative 1/2 power and do the antiderivative. So the antiderivative of that, we'll just keep this negative 1/6 flowing through. This is going to be, I'm going to leave a little space because I'm going to put something in here, that if I add a power and divide by that power, I would add a power and get a 1/2 power. I don't want to divide by a half, so instead I'll multiply by its reciprocal. And then let's clean this up. I'm going to put my u, I'm going to put this value back in for my u and turn it back into a square root. And then I'm going to put this stuff together. So that's going to become a negative 1/3. And then, like I said, we're going to turn that back into a square root. Put the 1 minus 4x cubed back in for the u. And then tack on our plus c. All right, so there is our antiderivative. So the key was looking for if it doesn't have a chain rule feel to it, and if I take the derivative of x cubed, I get x squared. So I have the correct pieces in there. So another one, similar, right? I have a square root in the denominator. The big difference on this one is that if I were to take the derivative of the inside, derivative of x squared, I don't have an x anywhere. So something else is going on this particular problem. It's not a u substitution, where this one had the right pieces going into it. So this is something else. This is a formula, right? So I have a value squared minus x squared, which ours has kind of that feel. So we're going to do the antiderivative, and it's going to turn into this. So what I need is to kind of figure out, it doesn't have exactly this look, so I'm going to do a little bit of a mini u substitution just for a second. And then I'm going to sub some things in and kind of finish it up. So let's see if we can try to make both of them fit here. Okay, all right, so let's start with kind of rewriting this a little bit as 1 over the square root of 36 minus 4x squared. And I'm going to pull that dx kind of off to the side. All right, so it very much now has kind of that look to it. But what I have is I'm going to do a little bit of a mini u substitution. So what I am going to do is not take 4x squared, but I'm going to take the fact that this really would come from a 2x being squared. So if I take a 2x and do the derivative of it, that gets me a 2dx. So if I pull the 2 over, that's a 1/2 du dx. And so what that allows me to do is to rewrite this a little cleaner. Because the formula has x squared, the formula does not have 4x squared. So what I'm going to do is write it like this. Square root of 36. And I'm going to take this piece squared, right? Instead of writing it as 4x squared, it came from a 2x that was being squared, but I'm going to take that 2x and replace it with the u. And so now it looks exactly like the formula. All right, but one piece that I'm missing, I had a constant along the way because I had to divide that over. So it's not just a du, it's a 1/2 du. I'll pull that 1/2 into the front. All right, so now what I have is I can do a 1/2 and I do the antiderivative. That 36 is my a value. Well, kind of, it's my a value squared. So I would have my a value would actually be 6 because I would be squaring that. And so if I apply the formula, I would have an inverse sine. Right? Then I got to have a fraction here. And currently, this value for us is a u. So it's going to be a u over our a value. A value is 6. And then plus c. So let's clean it up here a little bit. 1/2 inverse sine. And then my u value was, my u value was 2x. So I have a 2x over 6 plus c. And so one last little cleanup is 1/2 inverse sine x over 3 plus c. So we had to do a little bit of a u substitution, but a different kind of a u substitution because that didn't match perfectly the formula. And so we have to kind of rewrite it. And if it doesn't match perfectly, we're always going to have this little extra something that's going to be kind of integrated into the final answer. It's not a perfect one-to-one kind of a substitution into the formula because it didn't look exactly like that. But we made it look like that by doing a u substitution, and then we could do that. But then we had to plug in some other values and made our answer a little bit different than what we were expecting. So big difference was they have a similar feel. This is a traditional u substitution because the derivative of that inside does give us this piece, where the derivative of the x squared, we didn't have an x flowing anywhere around it. So, and then we'll do a couple more examples in the next video.